So today I want to explore the problem that we face, which is much more than a dilemma. It's a quadlemma in a way, or a quintlemma of how we manage our future energy demands and how we invest our resources in alternative forms of energy. And I'm going to spend most of this session talking about the possibilities and limitations of nuclear power. And this will provide a foundation for the lecture on next Tuesday, which will be particularly directed at wind, but more broadly at renewables. So first I'd like to have you consider the distribution of nuclear power plants in the world and really reflect on where they're not located and their high concentration, particularly in the eastern, midwestern part of the United States, but also in Europe. So within the U.S., you see that they're really concentrated up in the northeast, but also south and nearby Chicago. And California is quite striking in that in 1976, the state of California enacted a moratorium against new nuclear power plant development. If you look more closely at Europe, and particularly at France, you can see a very high dependence in some nations in the European Union on nuclear power. France now receives approximately 75% of its power from nuclear plants. And inside the United States, also there's quite a bit of variability and reliance on nuclear. So in Connecticut, for example, nearly 65% of the power that we consume in the state comes from nuclear plants in Niantic, which is about 45 miles to the east of us on the Thames River, from the Millstone nuclear power plants. So it's quite curious how different parts of the country, different economies have treated nuclear power, and explaining the cultural predisposition to accept the risks and accept the costs is not an easy thing to do. So just so you have an overview of the status of the nuclear industry in the world, there are about 436 different reactors that are operating in 30 different countries. 50 reactors are now under construction, mostly in Asian nations. And within the U.S., there are proposals for 20 new reactors. And of these, 4 to 8 may be online in 2020. China has 11 online at present, with 22 under construction, and is the nation where nuclear development is most rapid in the world. Within the U.S., the operating licenses that have had limits placed on them of operating licenses of between 30 and 40 years, most of these are going to be granted operating extensions. And the concern was that the plant or the infrastructure would not have the capability of lasting longer than 40 years at the outside. But they're finding that the engineering integrity of many of the plants is higher than they thought it might be. But this basically is a short-term lease on the problem of decommissioning these nuclear plants, and also what we'll be talking about in a few moments, which will be the problem of managing nuclear waste. The MIT report, the faculty report that was issued in 2003 and then recently updated that we've asked you to read, has some really, I think, important lessons and conclusions embedded within it. So they concluded that after 5 years from 2003, so this is 2 years ago, no new plants are under construction in the United States, and insufficient progress has been made on waste management. The sober warning is that if more is not done, nuclear power will diminish as a practical and timely option for climate change risk mitigation. So as one thinks about what our options are, particularly coal, as opposed to investments in renewables, as opposed to investments in nuclear power, you know, one might think about it as a problem of relative cost, but you also might think about relative risk and ease of bringing additional capacity online given the different sources. And underlying this, I think, is an underestimated cultural factor, which is what we worry about in the United States, and our predisposition to remember not just Chernobyl, but also what happened at 3 Mile Island in 1979. The capital costs of constructing a new plant are often enormous, and because so much can go wrong, including construction delays, that can cause interest rates to rise and the amount that has to be paid back to investors to rise. It's caused what's thought of as a risk premium being put on investment funds. So banks or private investment companies often will loan the money to a utility company that wants to build a new plant, but they will do so at a higher rate when it's measured by kilowatt hour. And so there's about a 2 cent per kilowatt hour difference between nuclear compared to coal and natural gas, which makes this a very, very expensive proposition. Basically, the money costs more. The legal and regulatory structure that surrounds nuclear power is rather complex. The initial statute that governed what now exists was the Atomic Energy Act back in 1954 that we discussed a bit during the beginning of the term when we were talking about atmospheric weapons testing. But recall that the technology, that the science and engineering foundation for nuclear power plants really evolved out of the nuclear weapons development program. So many of the nuclear power plants that were the earliest versions, say at Hanford or at Oak Ridge in Tennessee, these plants were first generation, but they were designed predominantly to provide enriched fuel for atomic weapons. This defines both state and federal authority concerning nuclear energy, and it really was the watershed that ended the monopoly, the government monopoly on nuclear technology. And it gave the private sector a role in nuclear development and expressly prohibited states from any role in transfer, delivery, receipt, acquisition, possession, or use of nuclear materials. And it also gave the Atomic Energy Commission the exclusive authority to manage these issues. And what is interesting about the history of the AEC is that they were both the promoters of the technology, the developers of the technology, and they were supposed to be the regulators. So the fox watching the hen house, so to speak. And this was recognized quite early in the history of the AEC when Congress decided to break off the responsibilities associated with regulation to have a higher probability of safety and environmental protection and worker safety, so that the Nuclear Regulatory Commission was given these responsibilities. So this is an independent agency now that has commissioners assigned to it that make choices about issuing licensing decisions and about safety violations or environmental violations associated with the industry. So that states have retained authority over electric power generation, sale, and transmission. Another aspect of the development of the nuclear industry, which is important to know, is that this is not being protected by private insurance companies. The Price-Anderson Nuclear Industries Indemnity Act really holds the industry harmless from damage claims in the event of a serious accident. And it also sets up a procedure for compensation that has criteria that are really pretty clear, that those that claim damage have to show what it was, they have to calculate their monetary loss, and they also have to demonstrate causality that is relatively easy to demonstrate in this case because of a specific isotope mixture signature that would come from any sort of a nuclear explosion or an accident. So the Nuclear Regulatory Commission was created in 1974. Now, you can imagine also that many states might be more worried about nuclear power than other states, and California is really a pretty good example of that. So that in 1976, the state of California created a moratorium on new nuclear power plant construction. So states might have the authority to do that, and until the federal government approved of methods to dispose of high-level waste, the state of California was really quite concerned about what the long-term costs might be to manage that waste, and also what the long-term costs might be associated with decommissioning the plant. So the Pacific Gas and Electric Company argued that the congressional intent to preempt state regulation of the nuclear industry was implicit in the Atomic Energy Act. So again, preemption is a critical legal tool that the industry relied upon in order to claimed that the state of California did not have authority to create this moratorium. So the Supreme Court eventually ruled on this case, and its finding is quite interesting. The federal government possesses exclusive regulatory authority over construction and operation of nuclear facilities and over radiological safety. And the states hold authority over decisions concerning the need for additional generating facilities, licensing, rate-making, land use, and planning. And the Supreme Court argued that federal law would preempt the moratorium if it was related to safety concerns. So that's an interesting idea. The federal government would be the experts in the area of risk assessment and environmental assessment. Thank you, Emily Jack Scott. You seem to have been quite successful, persuasive. So that if it's related to safety concerns, the court argued that California did not have the authority to establish a moratorium because it was worried about health effects or environmental dangers. But it concluded that the federal law would not preempt a moratorium if California's logic was based on economics. So if they were worried about cost considerations down the road. So a very interesting distinction that allowed this moratorium to be sustained. California's assertion that the legislature had enacted the moratorium based upon economic concerns was eventually accepted. So that the Nuclear Waste Policy Act of 1982 is important because most nuclear waste had been and is now being stored in or nearby nuclear power plants. So it's highly dispersed around the country. Think back on the U.S. map that I showed you with the different dots of the location of the plants. That's where the nuclear spent fuel, the fuel rods that are highly radioactive are being stored. Within Connecticut, this would include the Haddam Neck nuclear power plant that's now been closed. That's about 20 miles from Yale to the east, and it would also include the 3 Millstone plants over in Niantic. So that under this statute, the Department of Energy was granted the authority to begin to centralize a nuclear fuel reprocessing and repository. So basically just a storage facility where this waste could be handled until it might be reprocessed. But they were unable to open the facility, and by an amendment, the site at Yucca Mountain was established by DOE to be the single repository. So you can imagine that if you were the state of Nevada, you probably would not be too happy about that. But if you were the state of California, Connecticut, or any other state that had nuclear power plants, you'd be really happy about the prospect of getting rid of the waste that's sitting inside your state boundary. So this prompted a lot of litigation. Litigation on the part of Nevada that did not want the repository to be located there, and litigation on the part of other states, including the state of Washington most recently, arguing that they wanted their waste taken to this power plant, and that the Obama administration did not have the right to decide that this storage facility should not open. When one thinks about the location of either the plants or the storage facilities, you need to think carefully about evacuation requirements. So before the 3 Mile Island accident in Pennsylvania, the emergency response plans by nuclear power plants in the U.S. were voluntary. That's quite striking, given what the Atomic Energy Commission and the Nuclear Regulatory Commission understood about the potential for these nuclides to move over long distances being transported in the air. Now the plans have to cover a 10-mile radius. Now think about that, 10 miles, would that be sufficient? Well, we're about 20 miles from the nearest nuclear power plant here, but if you think about the Indian Point nuclear power plant outside of New York City, then you need to think about the capacity to move tens of millions of people away from a zone that would likely be highly contaminated in the event of a meltdown or an explosion or a serious fire, such as existed at 3 Mile Island or at Chernobyl. So the nuclear point facility prompted Governor Pataki to commission a report to evaluate the evacuation plan, and criticized the communication between local agencies, the size of the area that would be affected by a release, and the plan's premises that an orderly evacuation rather than mass panic would likely ensue. It's kind of interesting because if you drive around Connecticut within 10 miles of the nuclear power plants, occasionally you'll see a sign on the side of the road, sometimes very rural roads, that notify the public that this is part of an evacuation route in the event of a nuclear accident. So that the capacity to move people away from a contaminated zone, to be able to predict how that zone might vary given weather patterns, it really is quite limited. Also, there was no consideration of the probability or likelihood of a terrorist attack at these plants, and this raised the possibility that there ought to be aerial surveillance, that there ought to be planes that are flying nearby these nuclear power plants, as there was shortly after the 9/11 terrorist attack in New York. So that the Commission reported that any plant adjacent to high population areas should have different requirements than plants otherwise situated, because protective actions are more difficult and the consequences of failure or delay are higher. And the planning problems are more serious because of the large population concentrations. So, jump ahead here. The core problem associated with waste is radioactive half-life. And the key concern is over plutonium. And there are 270 tons of separated plutonium from reprocessing of fuel rods around the world that now are sitting at sites and being stored. And it has a half-life of roughly 24,000 years. So when engineers and safety experts were thinking about the problem posed by Yucca Mountain, this is the mountain in Nevada, where the storage facility has been partially constructed using about $9 billion of taxpayers' money. So that the problem really here was, how do you ensure the integrity of a storage facility for nearly 1 million years? And so they chose this site because of its remoteness. Poor Nevada. Remember, Nevada was also the site of the atmospheric weapons testing facility, the largest and most often used in the U.S. And they designed a machine that would bore into the rock and create a tunnel within which either canisters would be stored as dry fuel, or they could be stored in water. So the fuel is highly radioactive, and it's cooled in pools of water or in these dry casks, and it's currently stored at 66 sites in the U.S. This is what one of the storage facilities might look like in that honeycombed set of boxes that you can barely see in the bottom of the pool over here. That's how they store the fuel rods side by side. By the way, it also creates radioactive water, so that the amount of liquid waste that is contaminated is far larger in volume than the amount of waste that is either low-level or high-level waste. So it was also curious that if you're projecting out a risk management strategy over tens of thousands or hundreds of thousands of years, what happens if something occurs and society no longer speaks a language that is understood today? What if some massive accident occurred, nuclear war, whatever it is, that leads whatever society exists that stumbles across this plant to recognize it? Kind of interesting. It was in a way, it was a labeling issue. How do you communicate risk, not using language, but using symbols instead? So the Department of Energy commissioned anthropologists to think about different forms of symbolism, and they went back and looked at what symbols would best convey the idea that there was something extremely dangerous nearby or to stay away. And the symbolism that is chosen is not represented here, but the nuclear symbols that you see in the upper right-hand side of this slide are those that are commonly used by the nuclear industry. But you can imagine that if you'd never, if you did not know the culture today, if you'd never seen any symbol on the side of a truck, for example, sometimes trucks have some of these symbols, that you wouldn't have any idea what this meant. The symbols on the lower right are symbols that are commonly applied for industrial and worker safety situations, whereas the symbol on the left is several hundred years old. So that I mentioned a lawsuit. This most recent lawsuit this year, this spring, by Washington State versus the Department of Energy was designed to encourage the federal government to keep the Yucca Mountain repository viable. So the Attorney General McKenna made the right decision to file his lawsuit today to stop the Obama administration from closing down Yucca Mountain. Now, another problem with nuclear power is the potential for proliferation of nuclear weapons. So one might think that we need to think about an international strategy to control the distribution of nuclear fuel. So processed nuclear fuel could be further enriched to form a weapon grade that could produce nuclear weapons. So the International Atomic Energy Agency and several other private organizations banded together to encourage the creation of a nuclear fuel bank, so that the G8 has been proposed to constitute this bank and be responsible for the dissemination of nuclear fuel and then for its recovery once it's spent. In this way, they would have a collaborative attempt to try to manage the fuel. Thinking also about the MIT faculty's conclusions regarding safety, they ended their report saying that parallel with improved operations, the safety record of the nuclear industry has really been quite remarkable in the last 20 years. And it plays, the nuclear power industry displays by far the highest capacity factor among all generation technologies, providing now about 20% of the U.S. electrical supply. So that the belief is that most reactors, particularly the latest generation reactors, have the capacity to operate safely, but that the probability of bringing them online in a way that would make a significant difference in the world with respect to effects of energy consumption and climate change is really quite limited. So that with respect to the enrichment problem, for example, uranium, when it's mined, is approximately 0.7% uranium-235, but it needs to have that increased to 4 to 5% in order for it to be usable as fuel in a nuclear power plant, compared to 20% that it has to be for nuclear devices. Now, the 3 Mile Island example in 1979 created quite a bit of alarm in the United States, and it was also a time when a movie came out called The China Syndrome that dramatized the effects of a nuclear accident in an urban area. And the nuclear facility at 3 Mile Island experienced what was about a 60% meltdown. And you know, like most major accidents, whether or not it's the space shuttle that blew up, or the Bhopal incident in India, where it's estimated that more than 100,000 people were killed in a chemical plant explosion, or in Chernobyl, many people think about the problem being assigned to and caused by technical failure, technology failure, the hardware failure, when in fact it's almost always human failure to monitor equipment effectively, and that was certainly the case at 3 Mile Island when workers mistook the need to open a valve to allow cooling water to go in and cool down the fuel rods that were heating up. So in Bhopal, it was a problem of gauges. With the space shuttle blowing up, it was a problem of misrecognizing the heat shield tiles that had fallen off and that were highly temperature sensitive, so that the shuttle took off during temperature conditions that some recognized made it dangerous. So the case history that is most important, I think, for us to think about, which caused the greatest amount of environmental damage in history with respect to a nuclear power plant, occurred at the Chernobyl plant in Pripyat, then the Soviet, then within the Soviet Union. And this occurred in April of 1986 and occurred during a yearly maintenance operation where they were pursuing a gradual power reduction. And they basically lost control of their maintenance efforts, and the control rods were removed too quickly, and then the power shot back down too low, and the water in the plant was turned in the improper direction. The workers were confused about what to do. The power surged 1,500 times its safe level within 5 seconds, and a steel shield on the roof of the building was blown into the sky, and the entire facility caught fire for a period of several weeks. So 4 days later, after the Soviet Union had maintained their silence, the government announced an accident has occurred at the Chernobyl atomic power station. One of the nuclear reactors has been damaged. Measures are being taken to eliminate the consequences of the accident. Aid is being given to the victims, and a government commission has been established. So anyone who knows anything about industrial accidents or nuclear power plants would recognize that being able to warn the public immediately after an accident was exceptionally important. The only nuclear event that this could be compared to was one at Windscale, now known as Sellafield, in the northern part of Great Britain, where in 1956 there was a fire in the plant and a significant amount of radiation was released into the air, and the workers of the plant went out and commandeered the tractors and cars of farmers that lived in the surrounding area, and the farmers were standing in their field watching these workers basically drive away in a caravan as quickly as they could so that they could reduce their exposure. Again, no government warning, no attempt to evacuate the area, so that the failure to take action soon after an accident like this results in the population being exposed at the highest levels. So the Soviets then disclosed a certain leak of radioactive substances, and then finally told the public that 200 people were hospitalized, but the water and the air in Kiev were safe. They were reassuring the public, in fact, at the same time that their Air Force was seeding the clouds in the area, trying to induce rain so that it could wash the radiation from the sky before it reached the Russian state, and also to protect the reservoir that is to the south of, or to the north of Kiev. So finally, President Gorbachev in '86 came on the news one evening and said, "Good evening, comrades. All of you know that there's been an incredible misfortune. The accident at the Chernobyl plant has painfully affected the Soviet people and shocked the international community. And for the first time, we confront the real force of nuclear energy out of control." There are a variety of different stories and lessons here, but perhaps the one that is most sad is the way that workers were mistreated. The effects of being exposed to radiation in the absence of protective gear was very well known to the Atomic Energy Commission and to the Soviet scientific experts from their experiences with nuclear weapons. But other than potassium iodide pills and the normal kind of a suit that a fireman might wear as protective gear, they were left helpless, even though they were told to go in and try to put out the flames of the burning and charring fuel rods. So also the Soviets and others misunderstood the pattern of distribution of the radionuclides once they reached the atmosphere. So here you see April 26th, the white that you see in the right-hand side of the upper left air photo here is demonstrating the direction of the plume. By April 28th, the plume had reached up over Norway, Sweden, and Finland. By April 30th, you can tell that the plume was being dispersed and being blown back around northern Europe, and eventually by May 6th, it had scattered itself pretty much all over Europe with a patchy kind of a concentration. And you remember the surprise on the part of the Atomic Energy Commission to the patchiness of the fallout, finding high levels of strontium-90 in New York and Connecticut when the cloud intersected a rainstorm. And this affected a fallout pattern that was really quite similarly non-uniform in Europe. And it took roughly about 10 days for this plume to make its way all the way around the world, moving across China and then the Pacific Ocean to reach the United States, when it became detectable in the milk supplies in states such as Utah and Arizona and California. So that the sensors that existed at that point in time were picking up contaminants eventually distributed around the United States and eventually the rest of the world. So as you look at this map, you see a radiation deposition gradient from lightest color to darkest color. And what's so striking about it is that you see the patchiness demonstrated here, where you have a significant deposition in Austria, a significant deposition in Finland and up in both Norway and in Sweden. And the distance, by the way, is probably about 600 to 700 miles, maybe about 800 miles from Chernobyl up to northern Europe. So one thing that this did was it created complete chaos in European food markets. So if it reached the ground, it was getting into the food supply. Well, they realized that the different nations all had separate radiation standards, so that they did not have a uniform regulatory system to protect against one nation selling one commodity that had a radiation level that might not receive, or that might not be accepted by another nation that had a tougher standard. Also, the detection process, you can imagine that the government was slow to go out and try to figure out this patchiness with precision, and that had tremendous implications for the period of exposure by the population. So here's a good example of the distributional pattern as it was being recognized by the Soviet Union back in the late 1980s. And as they tested more, they found more, so that this map was constantly changing in response to more rigorous testing. So that the different zones that you see here are designated as confiscated areas, permanent control areas, period control areas, and unregulated areas. So that the darkest red are the confiscated areas. So that lands, agricultural lands, urban lands, homes, residential communities, commercial areas were literally confiscated, so that hundreds of thousands of people were moved off of their land because the soils, the plants, as well as the building materials and even the vehicles were contaminated. Hundreds of thousands of vehicles turned into hazardous waste, almost within a matter of days. So what to do with this area? What do you do with people that you're going to pull out of their homes? Well, they had to build new communities. And in some instances, they even built new communities in areas that were contaminated because they hadn't tested carefully enough. Kind of interesting, because it should ring bells with you with respect to the Bikini Island history, where the Bikinians were allowed to move back into an area that the government supplied funds for constructing new homes, and then they went in and tested that more carefully and found that they had to move out. So that the tension here is that the government will want to limit its own liability, its own costs for evacuating or for dealing with hazardous waste or for rebuilding a community. So it has very little incentive to disclose with precision the intensity of the concentrations. So in this case, the precision grew in response to international pressure, because they were finding the patchy highly contaminated areas in many different European communities. And those different countries wanted to have international authority to take the Soviet Union to court so that they could be compensated for their losses as well. The construction workers that were trying to put out the fire and then deal with the contaminated areas would drive vehicles in, whether they were aircraft, whether or not they were cars or trucks such as this, the workers eventually were suited up in protective gear, and they had to wash down the vehicles as they left the site to keep the vehicles from tracking the radionuclides to different parts of the affected area. I mentioned that agricultural lands were obviously affected, especially those within the red zones on the map that you just saw. What do you do with contaminated lands like this? Well, you basically have to scrape the surface off of it and figure out how you're going to bury the contaminated material. So that, think about this, 76,000 square kilometers of contaminated land. And what about the forest lands? What would happen to the timber that were growing in the area? Well, they also absorbed the radionuclides, and many of those trees are still standing. And many people would cut down the contaminated trees, cut the timber, saw it up, turn it into building material, and people would build their houses of it. There's a similar analogy to the way that the uranium mines created the fuel for the power plants, the way that those mines left waste of uranium mine tailings. So what do they do with that? Well, in some instances, they use the mine tailings as construction material for homes, and particularly on Native American reservations. So there's a very unhappy and costly history of how Navajos were living in homes that were built from cement products that contained uranium. So that the enormity of the effect of the contamination was just beyond anybody's expectation. Cars, trucks, tanks had to be buried, and there are many stories about how cars would be buried at night. They'd be dug up before dawn, and parts from those cars would then be removed and sold on a black market. So you all know that there's a very robust used car part market virtually everywhere in the world, so that these radioactive used parts were brought back, recycled back into circulation. In Sweden, it's interesting because the Swedes found out about this not because they were notified by the Soviets or any other nation, but because their workers showed up at their nuclear power plants and they started setting off alarms. So that the power plants in Sweden were shut down one after another, but not because there was a problem at their plant, but because the workers were walking in the door to the plant in the morning, and they had picked up the radionuclides that had been deposited on the streets or the sidewalks in Sweden, and that contamination had set off the alarms. That's when they started looking at weather patterns and trying to figure out what the source might be. There was no evidence that a nuclear weapon had been detonated, so they started looking at the location of nuclear power plants and were able to piece together the weather pattern over the past several days to pinpoint the Chernobyl plant. So that within several days, the radiation in Sweden was 1,000 times higher than it previously had been. So I'm going to jump ahead here to discussion about evacuation. Civil defense officials were finally able to convince the government and plant officials of the need to evacuate areas that were closest to the plant. But 36 hours had passed, and these are, if you look at the current charts about the periodicity of the release of the radiation, you find that this first 36 hours was a crucial period when that population should not have been allowed to stay in the area. So that they really had no plan. The government eventually was able to put together 1,000 buses and picked up first the children and then moved them hundreds of miles away to different camps. So as they studied the pattern of deposition, they found that their evacuation zone had been defined too narrowly. So the evacuation zone had to be continually expanded. So that by May 3rd, this was only about 6 or 7 days later, 45,000 residents had been evacuated from a 10-kilometer radius. Eventually, 210,000 people were resettled into less contaminated areas. By the way, if you take the United States requirement that every nuclear power plant in our nation have a an evacuation plan that would cover an area that is defined by a 10-mile radius, and you compare it to the movement of contamination from this plant, you can see the 10-mile radius in green here compared to the eventual location of the deep red colored confiscation zones more than 100 miles away. So I'm going to jump ahead here because I'm going to run out of time. The safety regulations varied quite highly among the different nations, leading to a chaotic set of bans. So that finally the Europeans decided to ban meat, live animals, and produce from all areas within 1,000 kilometers of the site. The economic consequences were enormous, so that the Austrian government banned the import of East Bloc milk, fruit, and vegetables. The Dutch Agricultural Ministry prohibited cattle grazing. The Swiss warned against providing fresh milk to young children. Italy banned the sale of its own leafy vegetables. And even the U.S. Was warning people not to go to several European nations because of the extent of the contamination. So the economic consequences just associated with the food supply and its contamination were far higher than anybody imagined. There's also a sad story about the same indigenous group in northern Sweden that have long relied upon the livestock of reindeer, and reindeer feed on moss and lichen, and the radionuclides built up heavily in the moss and lichen and were detectable in their meat within a matter of several days following the accident. So that the Swedish government decided that it was going to ban the sale of all future products from these animals except for the sale of furs. So to come to a conclusion here, I want you to, you'll be able to study this slide not from this lecture, but up on the classes server, so that if you think about the relative amount of radioactivity that was released by the first atomic bombs in Curies, you see the first atomic bombs up here on the top at Nagasaki and Hiroshima having released about 250,000 Curies. From atomic weapons testing totally during that period, the atmospheric weapons testing, those figures are given here. But then if you look down here at Chernobyl, you find that the estimates of exposure and the estimates of those exposed are really quite amazing. 17,400 fatal cancers were expected among 2.9 billion people exposed. So more than half of the world's population was exposed to fallout from this nuclear power plant explosion, with a very serious estimate of fatal cancer outcomes, compared to the atomic weapons testing program, where among everybody at the time this report was done, back in the 1990s by the National Cancer Institute, everybody in the world was anticipated to have been exposed, but only 12,000 fatal cancers were expected from that entire program. So the magnitude of exposure, the magnitude of risk is associated with this kind of a failure has long been underestimated. And I'm going to leave you at this time with one other thought, because I opened the lecture saying that we're facing a very difficult decision among how to allocate our resources and investments in different kinds of fuels. And I want you to think, too, about the relative risk associated with coal-fired power plants. We don't have too much time to talk about coal, but coal produces not just sulfur and nitrogen oxides, it produces particulates. And particulates, particularly in combination, particulates in combination with the sulfates pose a very serious health threat. And many people don't realize that between 20,000 and 60,000 premature deaths in the United States alone every year are now attributable to coal-fired power plants. On a world scale, the number is far more significant. So these are deaths that are premature deaths, particularly among those that have background conditions of cardiovascular illness or other kinds of respiratory illnesses. So that premature deaths from this form of energy are far higher than have ever been accounted for with respect to the nuclear industry. So that the coal has this image of being a relatively safe fuel compared to nuclear power, but I'm hoping to get you to rethink that. The nuclear waste issue, I think, is overwhelmingly persuasive to me that the nuclear industry should not be seriously encouraged. And I am disappointed and surprised by the Obama administration's support that came out just a few weeks ago for it. And on next Tuesday, we'll be talking about the future of renewables, and particularly the different kinds of legal strategies that have been employed, including tax strategies, different subsidies, different kinds of credit systems in order to try to increase human investment in renewable sources. So have a great weekend and enjoy the weather. So today I want to explore the problem that we face, which is much more than a dilemma. It's a quadlemma in a way, or a quintlemma of how we manage our future energy demands and how we invest our resources in alternative forms of energy. And I'm going to spend most of this session talking about the possibilities and limitations of nuclear power. And this will provide a foundation for the lecture on next Tuesday, which will be particularly directed at wind, but more broadly at renewables. So first I'd like to have you consider the distribution of nuclear power plants in the world and really reflect on where they're not located and their high concentration, particularly in the eastern, midwestern part of the United States, but also 5 miles to the east of us on the Thames River from the Millstone nuclear power plants. So it's quite curious how different parts of the country, different economies have treated nuclear power, and explaining the cultural predisposition to accept the risks and accept the costs is not an easy thing to do. So just so you have an overview of the status of the nuclear industry in the world, there are about 436 different reactors that are operating in 30 different countries. 50 reactors are now under construction, mostly in Asian nations. And within the U.S., there are proposals for 20 new reactors. And of these, 4 to 8 may be online in 2020. China has 11 online at present, with 22 under construction, and is the nation where nuclear development is most rapid. Has some really, I think, important lessons and conclusions embedded within it. So they concluded that after 5 years from 2003, so this is 2 years ago, no new plants are under construction in the United States, and insufficient progress has been made on waste management. The sober warning is that if more is not done, nuclear power will diminish as a practical and timely option for climate change risk mitigation. So as one thinks about what our options are, particularly coal, as opposed to investments in renewables, as opposed to investments in nuclear power, you know, one might think about it as a problem of relative cost, but you also might think about relative risk and ease of bringing additional capacity online, given the different sources. And underlying this, I think, is an underestimated cultural factor in Europe. So within the U.S., you see that they're really concentrated up in the Northeast, but also south and nearby Chicago. And California is quite striking in that in 1976, the state of California enacted a moratorium against new nuclear power plant development. If you look more closely at Europe, and particularly at France, you can see a very high dependence in some nations in the European Union on nuclear power. France now receives approximately 75% of its power from nuclear plants. And inside the United States, also there's quite a bit of variability in reliance on nuclear. So in Connecticut, for example, nearly 65% of the power that we consume in the state comes from nuclear plants in Niantic, which is about 40 in the world. Within the U.S., the operating licenses that have had limits placed on them of operating licenses of between 30 and 40 years, most of these are going to be granted operating extensions. And the concern was that the plant or the infrastructure would not have the capability of lasting longer than 40 years at the outside. But they're finding that the engineering integrity of many of the plants is higher than they thought it might be. But this basically is a short-term lease on the problem of decommissioning these nuclear plants, and also what we'll be talking about in a few moments, which will be the problem of managing nuclear waste. The MIT report, the faculty report that was issued in 2003 and then recently updated that we've asked you to read,